Good morning, ladies and gentlemen. Welcome to our another first lecture in this attempt to try to get you guys some work. Today we're going to look at solving exponential functions and logarithmic functions. The two essential questions that we'll be looking at are simple. First and foremost, how do I solve exponential functions? And secondly, how do I solve log functions? Well, here's the first thing you want to look at. When solving log functions, you'll be using what's called the change of base formula. The change of base formula is set up so that such as a, b, and x are real positive numbers. And please note that neither a nor b can be equal to 1. So looking at the change of base formula, you see that log a of x, when it's broken down, equals log of x over log of a. Once again, looking at the change of base formula, log base a of x equals log of x divided by log of a. Now, let's look at this in a realistic form. Let's evaluate this logarithm using our change of base formula. Log base 3 of 7, log base 3 of 7. Now, using our change of base formula, we can deduct that as we evaluate this, it'll be log 7 divided by log 3. So, log base 3 of 7 equals log 7 over log 3. Always remember that your base here will fall into your denominator while your product goes into the numerator. Now, let's look at our steps for solving equations. The steps are pretty much simple. Step 1. You want to isolate your base. So you want to make sure that there's nothing on the same side as the base and its exponent. So your base can be anything such as 3 to the x power or 2 to the x plus 1 power or any derivative of such. So first and foremost, you always want to isolate your base. Secondly, if you can rewrite your problem with the same base, do it. So that may mean that you may have a small number on one side and a big number on the other. We'll look at that shortly, but just know that you want to put your like bases together. So if you have 2 on one side and you have 4 on the other side, you want to rewrite that 4 to where it's like a base 2. So 2 to the first power will be on one side, and with like bases you will have 2 to the second power on the other side. What happens if you can't do that? Well, if you can't make the same base, you got a couple of options. First option is you can rewrite an exponential equation in log form. In other words, you take your base and make it into the base of your logarithm and do it to both sides. Or you can rewrite your log equation in exponential form. That's when we use what's called the circle method. We're using the circle method, you take that small number by the log and you make it the big number in your exponential. And then you take what number is on the other side of the equal side and make that your exponent, and you set that equal to your product. We'll look at that shortly. And always remember to check your answer to make sure that everything works. Let's look at our first example. 8x equals 23. 8 to the x power equals 23. Well, looking at this number, I know that I can't really find like bases. Now, following step 1, I've isolated my base because 8 to the x power is on one side by itself. So we've isolated. Now we'll look at our bases. I know that there are no common numbers between 8 and 23, so therefore I can't rewrite this with like bases. So I can't use like bases. I got to go to use what happens when we don't have like bases. So what we can do is we can take our base 8, because 8 is the base, and turn it into a log. So now we have log base 8 of 8 to the x power equals log base 8 of 23. Now notice when we took this 8 right here and we made it into our logarithm, we did it to both sides of our equation. Because this is an equation, what you do to one side, you do have to do to the other. So we have log base 8 to the x power equals log base 8 of 23. Now, what happens next? Well, what happens when we do our logarithms is that this log base 8 to the 8 cancels out, which leaves us with x. So when this here and this here will cancel each other out and leave us with our exponent, which is 8. And then we bring down the log 8 to the 23rd. Now, our next step is to use our change of base formula and convert it. So when we do that, we have our base 8 here. Base 8 goes in our denominator, and our product right here goes in our numerator. So log base 8 of 23 becomes log 23 divided by log 8. Now, depending on what the question is on the exam, you can leave it like this right here, or you can go ahead and put it in the calculator and solve it. But for our purposes of this demonstration, we'll leave it just like this. Our second example, e to the x equals 72. Now, when you see the e is a dead giveaway that we're not dealing with regular logs, but we're dealing with natural logs. So, because we can't do it like we don't have like basis, let's go ahead and apply our log change form. So in log change form, we have natural log e to the x equals natural log 72. Remember, this e automatically gives us a giveaway that we're looking at natural logs. So just like the previous problem, we have natural log of e to the x power equals natural log 72. Well, we cancel out this natural log and this e, which is going to leave us with just x. And we bring down the natural log of 72. Once again, we can put this in the calculator and get a numeric number, or we can leave it like this. Remember to check your directions on your question to tell you which way to do. Example number 3. 3 times 2 to the x power equals 42. 3 times 2 to the x power equals 42. And as you're watching this video, if we're going too fast, don't be afraid to press pause and finish writing or to think about what's going on. So here in this problem, because we have 3 times our base, we want to isolate the base. So to isolate the base, let's divide both sides by 3. When we divide our left side by 3, it cancels out our 3 and leaves us with 2 to the x power. On the right, 42 divided by 3 gives me 14. Now, what's my next step? Well, because we can't do like basis, simply put, all we do is apply our log base formula. So we take our 2 and make it the base of our logarithm. So we have log base 2 of 2 to the x power equals log base 2 of 14. Well, log base 2 and this 2 cancels out to leave us with just x. And now we have x equals log base 2 of 14. Now we apply the change of base formula and we have x equals log 14 divided by log 2. So remember, here we used our log base formula, and then here we used our change of base formula. Let's look at our next example. 2 times 3 to the 2t minus 5 power minus 4 equals 11. So our first step, using basic order of operations, we're going to subtract 4 from both sides. When we subtract 4 from both sides, we now have 2 times 3 to the 2t minus 5 power equals 15. 2 times 3 to the 2t minus 5 power equals 15. Well, we're still trying to isolate the base, so since we're isolating the base, let's divide both sides by 2. When we divide both sides by 2, this is what we now have. 3 to the 2t minus 5 equals 15 over 2. Now let's retract. We added 4 to both sides, so this 11 became 15, and now we divided by 2, so now we're at our new equation. So what's next? Well, we use our log base formula. We have a base 3 here. So since we have base 3 here, let's go ahead and change that to log base 3 of 3 times 2t minus 5 equals log base 3 15 over 2. And just like we've been doing, this log 3 and this 3 will cancel out to leave me with 2t minus 5 equals log base 3 15 over 2. Now this one might get a little complicated, but just follow your standard order of operations. So let's add 5 to both sides, and now we have 2t equals log base 3 15 over 2 plus 5. Now you can't combine these numbers right here because this 5, when it was over here, didn't have a log attached to it, while this 15 over 2 does have a log. So since it's that way, all we have to do is add 5 to both sides. Now we're still trying to get this t by itself because we're still solving for our unknown, so we just eventually divide both sides by 2, and this is what we're left with. It looks complex, but it's really not. Log base 3 15 over 2 plus 5, all divided by 2. We now have 3 times e raised to the 0.5x power plus 2 equals 5. Basic order of operations, let's subtract 2 from both sides. We subtracted 2 from both sides. Now we're left with 3 times e to the 0.5x power equals 3. Now, still following basic order of operations, we can divide both sides by 3 to leave us with e to the 0.5x power equals 1. Now, because we have this e here, we do have to apply natural log in the situation. So now we have natural log of e to the 0.5x power equals natural log 1. This natural log and this e right here cancels out, and so now we're left with 0.5x equals natural log 1. And basic math tells me that natural log of 1 is 0, so if we would divide both sides by 0.5, we would still have 0. So remember, natural log of 1 gives us 0. Let's look at one more example before our time runs out. We have 2 times log base 5 3x equals 4. 2 times log base 5 3x equals 4. Let's divide both sides by 2. So we divide both sides by 2. We now have log base 5 3x equals 2. Now when you have the log function right here, this is when using your circle method comes in handy. So let's convert this using the circle method. Let's take our base 5 right here. Our base 5 becomes the base of our exponent function. So instead of us going having this, we can now convert it, multiplying by 5. And like I said, let's use the circle method to come now 3x equals 5 squared. So in a sense, we took this 5 right here, this base 5 of our log, and made it the base of our exponential function. We took this number right here and made it the exponent of our function. And we brought down our 3x. 3x equals 5 squared. Well, 5 squared gives me 25. Now we can follow basic math rules. 25 divided by 3 is 25 over 3, or if you're putting in a decimal, it'll be something like 8.333. Well, we're going to pick up here with our next video. Hope this helps out, and remember, we can go back or we can press pause if you need to. Have a great day.